Hi students, good morning. I hope you all are fine. Welcome to grade 12 business mathematics class. We are learning our second chapter integral calculus. Almost we have completed two more exercises are left. That is a small section. Okay. So today we will start the next section, gamma integral. In our last class I gave all the gamma integral, that formulas, everything I gave. First we will recall all the formulas. And the reason is we are going to use the formulas here to solve the problems. Okay, so last class I gave some work for you. I hope you all completed. Okay, so let's move to the, I hope you all take down everything to your notes. That day itself I marked and gave whatever the things you need to take to your note. I hope you all of you completed. So just I am going to recall the properties first. Okay, first the main thing in this here is, is a formula. The section name is gamma integral. That's one more main thing, that's the formula, that is integral 0 to infinity x power n minus 1 e power minus x dx is known as gamma function. Okay, but the formula is integral 0 to infinity x power n e power minus ax dx is equal to n factorial divided by a power n plus 1. This is a main formula we will use here. Okay, so integral 0 to infinity x power n e power minus ax dx, if it is given is in the form means we will write as n factorial by a power n plus 1. Then we have learned some properties. Okay, that using that properties we will solve the problem. So one by one property just I will recall now. First one is gamma of n is equal to n minus 1 into gamma of n minus 1. It will be possible when n is greater than 1. Then second property is gamma of n plus 1 is equal to n into gamma of n, where n is greater than 0. The third property is gamma of n plus 1 is equal to n factorial. N is a positive integer. Okay, n is a positive integer. The fourth one is gamma of 1 by 2 is equal to, the value is root of pi. So these are the four things we need to know in this gamma integral. Then that formula, integral 0 to infinity x power n e power minus ax dx is equal to. Okay, so if one question they gave us, at once you need to check it in which what property we can apply there. Okay, so let's move to the problem. When you are doing the problem, you will get idea. So only one problem is in example, then exercise 2 problems are there. We will complete it today. Okay, let's move to the next. Question is example 2.80. Evaluate. First Roman is gamma of 6. The second one is gamma of 7 by 2. Third one is 0 to infinity e power minus 2x x power 5 dx. Then fourth one is integral of 0 to infinity e power minus x square dx. 4 Romans are there. Okay, one by one we will do solution. First Roman, gamma of 6. So here it is given as gamma of 6. Okay, so first you need to check it in which formula we can use here. Okay, so if n is a positive integer, we can apply the third property. Okay, so n greater than 0 means second property, first property n greater than 1. Okay, so here this one it will be very easy when you are applying the third property. How much? We can write by using the third property. Our third property is gamma of n plus 1 is equal to n factorial. Okay, so first you need to write this gamma of 6 in the form of n plus 1. So n plus 1 means how will you write? 5 plus 1. Okay, so first you need to write the 6 in the form of 5 plus 6. Whether this 5 is a positive integer? Yes, that's equal to, this can be written as n factorial. Here what's the n value? In the place of n what's there? 5. So 5 factorial, this is the answer, that is 5 into 4 into 3 into 2 into 1, is it right? So 5 4s are 20, 20 into 3 is 60, 60 into 2 is 120 is the answer for this question. Understand? Really easy. Okay. Okay, let's move to the second. Second one, listen here very carefully. 7 by 2. Okay, so this one also we will use which property we will use in this? We will use the second property. Why means n is greater than 0. So if we are using that property, it will be very easy for us. So our second property is, what's the second property? Gamma of n plus 1 is equal to n into gamma of n. Okay, so first you need to write it in the form of n plus 1. Okay, so how will you write it in the form of n plus 1? N plus 1, 5 by 2 plus 1. Check it whether it is 7 by 2. 5 plus 2, 7 by 2, correct? Now we have wrote this in the form of n plus 1. Okay, so n plus 1 can be written as, in the, how will you write? N into gamma of n. Here n value is 5 by 2, gamma of n means 5 by 2, is it right? So again you apply the formula. Again when you are applying the formula means 5 by 2 you can keep it outside. This gamma of 5 by 2 can be written as in the form of n plus 1. How will you write in the form of n plus 1? 3 by 2 plus 1. Check it whether it is 5 by 2. Yes. So again you can use that formula. So 5 by 2 into 3 by 2 into gamma of n, is it right? That is 3 by 2. So again you can use the formula 5 by 2 into 3 by 2 into, again you split it in the form of n plus 1. So 1 by 2 plus 1, correct? So then again we can use the formula 5 by 2 into 3 by 2 into n gamma, is it right? That is 1 by 2 into gamma of n. Okay, so gamma of n means 1 by 2. Now using the fourth property, we know the value of gamma of 1 by 2. What's the value? Root pi. In the place of this one you can apply the root pi. So how much you will get? 5 by 2 into 3 by 2 into 1 by 2 into root of pi. Now multiply denominator 8, you will get 5 into 3, 15 you will get. This is the answer. Understand students? Don't confuse. So each and every step again and again we are using the second property. So first what will you do? For 7 by 2 is there. So 5 by 2 plus 1. You can split this in the form of n plus 1. So n plus 1 means again what will you do? N plus 1 means n into n gamma of n. Okay. So n into gamma of n. Then 5 by 2 you can keep it outside. Then this can be written as in the form of n plus 1. Again this will be, you can written as n into gamma of n. So 3 times you are applying the formula here. At last if you get gamma of 1 by 2, you know the value of gamma of 1 by 2 as root pi. That is by using the property 4. So if you apply the value and if you multiply, you will get the answer. Understand students? I hope you got it. Let's move to the next problem. Third Roman is, question is e power 0 to infinity e power minus 2x e power minus 2x x power 5 dx. Okay, so in this problem we can compare with the given formula. We know the formula, is it right? What's the formula? Main formula 0 to infinity x power n e power minus ax dx is equal to n factorial divided by a power n plus 1. So here you can use this formula. Why means both are same, is it right? So here you can compare with this one. Question. What's the question? 0 to infinity, we can rearrange x power 5 into e power minus 2x dx. Okay, so in the place of n, what's there? 5. In the place of a, what's there here? Minus. So here also minus. So minus no need, 2. Is it right? Now applying the formula n factorial means what's the value? 5 factorial divided by a value 2 power 5 plus 1. So the answer is 5 factorial divided by 2 power 6. This is the answer. Understand? So very easy. Is it right? Just you compare with the formula and write down n and a value and apply the formula. So before, when you are starting to learn this, please learn all the 4 properties and this formula. Okay, then only gamma interval will be easy for you. Okay, so one more question is there in example. Problem number 4. Integral of 0 to infinity e power minus x square dx. Okay, so it will be somewhat different. The reason is e power minus x square. So here we need to use by substitution method. Okay, otherwise it will be easy for you. Okay, for that we can use the substitution method here. So let us consider z t or anything. I am consider as t. Okay, so let t is equal to x square. So I am considering this t as x square means, so dt, what's the value you will get from that? 2x dx you will get, is it right? But we need the value of dx alone, is it right? So from this find out the dx value. Dx is equal to dt by 2x. Am I right? Yes. So when you are finding the limit at once, so by using the substitution at once you need to change the limit, is it right? Already I taught you. So x for 0 and infinity. So for t when you are applying, what will happen? Limit won't change, that is 0 square, infinity square, so infinity only you will get. So now dx is equal to dt divided by, we need to write it. So from this one you can find the root t value, is it right? So t is equal to x square. From that if you need x value means what will happen? Root t, is it right? So you can substitute this x value here. Y means, the reason is we need everything in the form of t, is it right? So you need to substitute this value here. Okay, now you can substitute in the given question, that is 0 to infinity e power minus x square means t, is it right? So dx means dt divided by 2 root t. Okay, so that's equal to 1 by 2 you can take outside. So 0 to infinity e power minus t dt by root t is there. So that's equal to 1 by 2 into 0 to infinity, bring this 2 up, so t power minus 1 by 2 e power minus t dt. Okay, now you can how we need to write it is, that is n factorial, that is gamma of n is equal to integral of 0 to infinity x power n minus 1 e power minus x dx. I taught you, is it right? So we need to write it in this form as gamma of n minus 1. We can write, so integral of 0 to infinity t power, shall I write this minus 1 by 2 as 1 by 2 minus 1, check it whether you got minus 1 by 2, correct. Okay, y means the reason is we need to write it in the form of n minus 1, so e power minus t dt. Okay, so that's equal to 1 by 2 into, how we can write, this is same as if it is in the form of gamma of n minus 1 e power minus x means, how we can write gamma of n, is it right? So gamma of n, is it right, is equal to gamma of n. So here gamma of n, in the place of n what's there? 1 by 2. So gamma of 1 by 2. So what's the value of gamma of 1 by 2? Last problem I taught you, into root pi. So the answer is root pi by 2. Understand? Understand? Very easy. Don't get confusion. So first you consider t as x square. From that you find out the x value, as well as you differentiate and find out dx value and substitute here. At last what you need to do, we get this like this. But then n minus 1 you need. So we change this minus 1 by 2 in the form of n minus 1. So this can be written as gamma of n. So gamma of 1 by 2, the value is root pi. From that root pi by 2. Understand? So this is only one example in gamma integral. So in exercise problem, 3 problems I gave you homework for you. Remaining we will do in our class. Okay. So all of you take down your books. Children, page number 51. Okay. Page number 51. Mark down the homeworks first. Exercise 2.10. Your homework is exercise 2.10. Problem number 1. This is same as first Roman in example. Okay. Then second Roman, that is same as second Roman in example. Okay. Then fourth problem you need to do. That fourth problem is same as third Roman. Okay. So remaining 3 problems we will do now. Understand, students? So what is the homework? Exercise 2.10. Problem number first Roman. First problem, second problem and fourth problem is a homework. Everything we have did in example. So same moral you need to proceed. Understand? So 3 more problems are left. We will do that. Now exercise 2.10. First Roman, that is third problem. Okay. Question is 0 to infinity e power minus mx x power 6 dx. This is also very easy, same as our example, but the m is there, because of that I started to do this. Okay. So you can compare with this formula, that is integral of 0 to infinity. What's the formula? Integral of 0 to infinity x power n e power minus ax dx is equal to n factorial divided by a power n plus 1. here in this problem, in the place of n, what's there? 6 is there. In the place of a, what's there? M is there. So you can substitute in this formula. So what will happen? Solution. Substitute in the formula. N factorial means 6 factorial divided by m power 6 plus 1. So what's the answer? 6 factorial divided by m power 7. This is the answer. Understand, students? Okay, very easy. Okay. Next problem, fifth one we need to do. That is integral of 0 to infinity e power minus x by 2 x power 5 dx. Okay. So this also we can use by same as the previous problem. That is integral of 0 to infinity x power n e power minus ax dx is equal to n factorial divided by a power n plus 1. Is it right? So in the place of n, what's there? X power n, that is 5. Is it right? What's the a value? Minus x by 2 is there. Is it right? So what's the coefficient of x here? 1 by 2 is the a value. Understand? So don't get confusion. 1 by 2 is the a value. Now apply here. So what will happen? 5 factorial divided by 1 by 2 power 5 plus 1. So what's the answer? 5 factorial divided by 1 by 2 the whole power 6. So if it's come to the numerator, what will happen? 5 you can bring all the terms to the numerator. So 5 factorial into 2 power 6. This is the answer. So 2 power 6 into 5 factorial is the answer. Understand? So very easy, but you need to learn the small formula. That's very, very important. Understand? Okay. So one more problem is left. We can do now. If f of x is equal to x square e power minus 2x, x greater than or equal to 0, otherwise then evaluate integral of 0 to infinity f of x dx. Okay, so x square e power minus 2x, x greater than or equal to 0, then 0 otherwise. Okay, so x is greater than or equal to 0, integral of f of x dx. So here what's the f of x value? This one is the f of x value. So in the place of f of x, you need to apply that one and remaining everything same. Okay. So f of x is equal to here, f of x is equal to x square e power minus 2x is a f of x value. Now apply that. First you write the formula. Integral 0 to infinity x power n e power minus ax dx is equal to n factorial divided by a power n plus 1. That's equal to integral of 0 to infinity x square e power minus 2x dx. Here what's the n value? N equal to 2. Correct? A value 2. Apply there. So what will happen? 2 factorial divided by 2 power n value 2 plus 1. So what's the thing you will get? 2 factorial divided by 2 cube. That's equal to 2 factorial, the value is 2. 2 cube, the value is 8. You can cancel. So 1 by 4 is the required answer. Understand, students? This all the things in gamma integral. So very, very small section. Maybe 2 marks they can ask. But it's a very important section. This gamma integral is very, very important section. But it's a small section. Okay, just they gave the indirection and the symbol and the basic thing only. So I hope you got good idea. Please learn out the formulas and properties and afterwards start to learn. Then only it will be easy for you. Otherwise you will feel very difficult. Okay. So gamma integral, the section is over. 3 more example, 3 exercise I gave the homework. Okay. So 3 simple problems. So please complete that. Okay, students. Okay. So I think we can start the next section. That's the last section in this chapter. So if you completed this section, this unit will be over. Okay. The last section is definite integral as the limit of a sum. Section name is definite integral as the limit of the sum. Okay. Please students take down your books, all of you. Now I will give just the formulas and indirections. So next class we will start the problems. Okay. So take down your books. So what are the things you need to take down to your note? First I am saying, so please take down your note after completing the gamma integral. Put the heading definite integral as the limit of the sum. Start from here and complete this one. Then again the following, cut this following and write up to here. Okay, so up to here you need to copy to your note. Why must this all the things you need to learn? Understand, students? So after completing gamma integral, please put the heading definite integral as the limit of the sum and start from here and write up to there. Okay, so just I will introduce now. So problems and all we will do in the next class. Okay, so first one, let f of x be a continuous real function in a closed interval a comma b which is divided into n equal parts of width h. Okay, so there is one f of x be the continuous real valued function. Okay, there is one continuous real valued function which will be in the closed interval a comma b. Okay, so we are going to divide this particular f of x in equal parts. Okay, that is n equal parts. That particular width is h. Okay, so for that we are going to learn two things. First one is integral of a to a f of x dx is equal to limit n tends to infinity, h tends to 0. Keep it in mind, n is tends to infinity, h tends to 0, h of a plus f of a plus h plus f of a plus 2h plus etc. Like this. Or integral a to b f of x dx is equal to, this is a thing we will use in all the problems. Okay, so you need to by heart this, that is integral of a to b f of x dx can be limit n tends to infinity, h tends to 0, summation r equal to 1 to n h of f of a plus h. So here what will you do means, we will find the h value. In all the problems we will find the width first. Afterwards we will find a plus rh and we will substitute in this formula and simplify and we will find the answer. Understand? So in each and every problem we need to find the h value, that is width we need to find. Afterwards f of a plus rh value you will find, and afterwards if you substitute in this formula you will get the answer. Okay, so h how will you find means b minus a by n. So b minus a means upper integral minus lower integral divided by n, that is the equal parts, how they are divided. So using this formula we will find out h and afterwards f of a plus rh we will find. Afterwards we will substitute in this formula. That's all. Then these are the things you have learned in the last year. 10th standard, is it right? So natural numbers means what's the formula? N into n plus 1 by 2. This can be written as summation r equal to 1 to n r, is it right? Natural number. Then square means summation r equal to 1 to r equal to n, is it right? So that will be simply write as r square. This is a formula for q. So this also you just go through. So natural numbers means n, is it right? So n into n plus 1 into but divided by 2. This can be written as summation r equal to 1 to n r. Square means n into n plus 1 into 2n plus 1 divided by 6 r square. Okay, then r cube means n into n plus 1 by 2 the whole square. These three formulas you have learned the last year. That's the same, not last year, 10th standard. So your important section, second unit you have learned. Okay, you know all this thing. So this one is also important. Okay, that is in summation how will you write. Okay, so these are the things you need to know before when you are doing the problem. If you know this all the things, it will be very easy for you. Okay, so this is the main formula. Just we will recall today's class. I started gamma integral today and I gave 4 properties. Then one very important thing is there is a one value in, do you know, gamma of 1. What's the value of gamma of 1? Maybe in one verse they can ask. It will be very important. So gamma of 1, the value is 1. Okay, what's the value of gamma of 1? 1. As well as gamma of 1 by 2, what's the value? Root pi. Okay, so these two things they can ask in one verse. So it will be very important. Then example 2.804 subdivision we have completed. So one formula I taught, then 4 properties. So using that we are doing. So the exercise 3 problems I gave homework for you. Please students, all of you take down your notes. Take down everything to your notes and copy the classwork. Afterwards please do the 3 homeworks and afterwards put the heading. Write down this two. This is a main formula we'll use here, this formula. And this all the things you have learned in last year. Anyhow you need to take to your note. Okay. So after completing whatever I gave now and afterwards please write down example 2.81 in your note. I will give the solution in our next class. So this section is also a very small section. I think 3 problems are there in the example, then 4 problems are there in exercise. I will complete in one class. So I hope to complete the next section in our next class. So this is the last section in this chapter. So learn it thoroughly, don't leave anything. Okay students, we will meet in the next class. Thank you. Before that, complete everything. Thank you so much.